Properties of logarithms can be useful in simplifying many calculations. But before we learn the properties of logarithms, we should teach ourselves on how to switch between logarithmic and exponential notations. We will convert the equation 3 power 2 equal to 9, which is in exponential notation, to logarithmic notation. It will be log 3 of 9 equals 2. Here 3 is the base of exponent, 9 the result of exponent, and 2 the power of exponent. Another example is 5 power 2 equals 25. In logarithmic form, it will be log 5 of 25 equals 2, where 5 is the base of exponent, also the base of logarithm. 25 the result of exponent, and 2 the power of exponent. Now we'll convert from logarithm to exponential notation. Consider the expression log 2 of 8 equals 3. In exponential notation, it will be 2 power 3 equals 8. Now let's deal with the real stuff. The first property is log base b of 1 equals 0. Here b represents any number. As an example, log 5 of 1 equals 0. Since 5 power 0 equals 1, you can use a calculator to prove. Second property is log base b of b equals 1. An example is log 5 of 5 equals 1, since 5 power 1 equals 5. Next, the inverse property, which is log b of b power x equals x. If we write this property in exponential notation, it will be b power x equals b power x. Since the bases are the same, it's equivalent to x. As an example, if you need to solve log 100, you can write it as log 10 of 10 power and apply this property to get 2. Another form of inverse property is b power log b of x equals x, where x is greater than 0. If we rewrite it in logarithmic form, it will be log b of x equals log b of x. Since the base of logarithms are equal, it's equivalent to x. As an example, if you need to evaluate e power natural logarithm of 7, you can rewrite it as e power log e of 7, and then apply this property to get 7. Next property is one-to-one property, which is log b of m is equivalent to log b of n if and only if m is equivalent to n. Notice the bases are the same. We can use this property to solve the equation like log 3 of 3x equals log 3 of 2x plus 5 for the unknown x. Since the bases are equal, we can set the argument 3x and 2x plus 5 equal. Then subtract 2x from both sides of the equation to get x equals 5. Another property is product rule, which is log b of mn is equivalent to log b of m plus log b of n, where b is greater than 0. An example is log 3 of 30x times 3x plus 4. We will expand this expression using product rule. First, we will express 30 as a product of primes, which is 2 times 3 times 5. Next, we will express the equivalent equation as a sum of logarithms of each factor, which is log 3 of 2 plus log 3 of 3 plus log 3 of 5 plus log 3 of x plus log 3 of 3x plus 4. Next property is quotient rule, which is log b of m divided by n is equivalent to log b of m minus log b of n. I will use quotient rule to expand the following expression. Note, the quotients are in factored form and in lowest terms, so we apply the quotient rule directly, which will give us log 2 of 15x times x minus 1 minus log 2 of 3x plus 4 times 2 minus x. Notice that the resulting terms are logarithms of product. To expand completely, we apply the product rule. I will leave that for you. Remembering the prime factors of 15 are 3 and 5. Another property is power rule, which is log b of m power n is equivalent to n log b of m. As an example, I will expand log 2 of x power 5. In this expression, the exponent is 5 and the base is x. So I will rewrite the equivalent expression by multiplying the exponent times the logarithm of the base, which is 5 log 2 of x. I will also simplify log root of x as an example. First, we will write log root of x as log x raised to half. Then apply power rule, which will give us half log x. You won't apply these properties in isolation. Rather, you use different properties to solve a given problem. I will expand this expression to demonstrate that point. Log x squared times y cubed divided by z power 4. Because you have a quotient of two expressions, we will apply quotient rule. This rule will give us log x squared times y cubed minus log z power 4. Because you have a product in the first term, we will use product rule. This will give us log x squared plus log y cubed minus log z power 4. Lastly, we use the power rule on all terms to get 2 log x plus 3 log y minus 4 log z, and that is it.